Welcome to the deep dive. Today, we're going to be taking a deep dive into the world of DevOps and cloud computing, a topic I know you've been curious about because you sent over a ton of material,
Yeah.
including some technical documentation and even some DevOps interview questions. But don't worry, we're not going to put you on the spot.
Right.
We're going to be breaking down these complex concepts and exploring servers, networks, and deployments in a way that makes sense.
Yeah, it's a fascinating field. And we're going to make sure that by the end of this deep dive,
Okay,
you understand the key ideas and why they matter.
perfect. So let's just jump right in.
Yeah.
I see we're starting with some pretty foundational ideas here. VPCs, bastion hosts, and VPC peering.
Right.
What I'm really curious about is what exactly is a VPC?
Yeah, so think of a VPC like a virtual private cloud,
Okay.
like having your own private office building in a bustling city.
Okay.
It's a space within a larger cloud network that you have complete control over. You decide who comes in, what they can access, and how everything is set up.
So it's not just about having space in the cloud. It's about having a secure and controlled space.
Exactly. It's about security, privacy, and control
Okay.
over your valuable data and applications. You get to set up the network within your VPC.
Right.
You control the IP addresses, and you decide how it connects to the outside world.
So you're like the architect and the security chief of your own little cloud city.
That's a great way to put it.
I like that analogy. Okay,
Yeah.
now what about these bastion hosts?
Yeah.
What role do they play in our cloud office building?
Great question. So bastion hosts are like highly trained security guards at the entrance to your building. They act as a secure gateway,
Okay.
allowing authorized personnel, which in this case would be users or administrators, to access resources within your private network.
So users connect to the bastion host first,
Yeah.
and then from there they can reach the resources inside the VPC.
Exactly. It adds that extra layer of security, making sure only the right people can get to those sensitive resources.
Okay, that makes sense. Now we have our secure office building in the cloud,
Right.
carefully guarded by our bastion host. But what if we have multiple office buildings or multiple VPCs and we need them to communicate with each other?
Yeah. That's a great question. And that's where VPC peering comes in.
Okay.
So imagine building sky bridges between those buildings,
Okay.
creating secure pathways for data to flow between them. VPC peering allows you to connect different VTCs,
Okay.
enabling resources in different virtual networks to communicate directly and securely.
So it's like creating a private network of cloud buildings,
Yeah,
all interconnected and working together.
it is.
Ah.
And that kind of controlled communication is essential for building those complex cloud applications
Okay.
and ensuring smooth data flow.
All right, we've got our secure cloud city up and running.
Right.
But how do we actually get things done in this environment? How do we go from writing code to having a functioning application?
That's where the magic of DevOps comes in.
All right.
And it starts with an interesting tool called Jira.
Okay, Jira. I've heard of that is used for project management, right?
Yes, exactly. It's like the central command center for a DevOps team.
Okay.
Developers can track their tasks, their progress. They can collaborate all within Jira.
Okay.
Imagine this. A developer finishes writing code for a new feature. They've tested it, and they go into Jira, and they mark that task as done.
Okay. And what happens next?
This is where things get really interesting.
Okay.
In a well-designed DevOps setup, that simple done can trigger a cascade of automated processes.
Wait, so things start happening automatically just because someone clicked done in Jira?
You got it. This is where the CI/CD pipeline kicks in.
Okay.
Think of it like an automated assembly line for software.
Okay.
Tools like GitLab CI or GitHub Actions step in to automatically merge the new code run tests to make sure everything is working as expected, and then they package the application for deployment.
So we're talking about automating a huge chunk of the software development process.
Exactly.
That sounds incredibly efficient.
It is. Automation is a core principle of DevOps.
All right.
It reduces errors, it speeds up development cycles,
Right.
and it frees up developers to focus on what they do best, which is writing code and building great features.
Yeah, I'm starting to see how DevOps can really transform the way software is built and delivered.
Yeah.
So we've automated the building and testing of the application, but how do we actually get it deployed and running in the cloud?
Right, so that's where deployment tools come into play.
Okay.
These tools are like expert orchestra conductors.
Okay.
They take the prepared application and they ensure that it's deployed to the right environment, that it's configured properly, and that it's running smoothly.
Okay.
Tools like Kubernetes Helm and Docker Swarm are really popular choices in the DevOps world.
So these tools handle all those complex details of getting the application up and running in the cloud.
Exactly. They manage the orchestration. They ensure that the right containers are running, that resources are allocated efficiently, and that the application is scaling to meet demand.
It's amazing how much automation is involved in taking an application from a developer's computer to a live environment.
It is.
Now, I'm guessing as our application grows and gets more users, we need to start thinking about how to handle all that traffic.
Absolutely. As that user base expands,
Right.
you need a strategy to distribute traffic and ensure smooth performance, even under heavy load.
Yeah.
That's where load balancers come in.
Okay.
Think of them as traffic cops at a busy intersection,
Okay.
directing traffic to different servers to prevent any single server from being overwhelmed.
So it's about making sure the system can handle the influx of users, especially during peak times.
Exactly. Load balancing is crucial for ensuring reliability and scalability,
Right.
especially for applications that experience those fluctuations in traffic.
Okay. Now, speaking of keeping things running smoothly, what about security?
Yeah.
How do we make sure that our cloud applications are protected from malicious attacks?
Security is paramount in the cloud, and there are a lot of different strategies that DevOps engineers employ.
Okay.
One interesting concept is CloudNAT, which stands for Network Address Translation,
Okay.
and it allows instances within a private network to access the internet without exposing their IP addresses directly.
So it's like having a secure middleman.
Yeah, you can think about it that way.
Okay.
Imagine you have a team working on a sensitive project. You want them to be able to access information on the internet,
Right.
but you don't want to expose their individual computers to the outside world.
Right.
CloudNAT acts as that protective barrier, allowing outgoing communication
Okay.
while shielding the internal network from incoming traffic.
That makes sense. It's about adding another layer of security to protect sensitive data and resources.
It's just one of the many security measures
Right.
that DevOps teams implement to ensure that their applications are safeguarded against a wide range of threats.
Okay, so we have our secure cloud city.
Right.
We've automated the process of getting code live.
And we're using load balancers and CloudNAT to manage traffic and security.
Yeah.
What's next in our DevOps journey?
Now, let's face it, even with the best planning and security measures, sometimes things don't go as planned.
Right.
So next, we'll explore how DevOps teams handle those inevitable bumps in the road.
Okay. Yeah.
And one of those bumps in the road can be incidents like outages or crashes.
Oh, yeah, those are never fun.
No, they're not. And that's where the real test of a DevOps engineer's skill comes in. Incident resolution.
Okay, so imagine this scenario. You're a DevOps engineer, maybe enjoying a relaxing evening, when suddenly your phone explodes with alerts, a critical production server has crashed, and things are going haywire.
Yeah, it's all hands on deck.
Oh, no.
The first thing you do is gather information. You need to understand what systems are affected,
Right.
what error messages are popping up, and how many users are being impacted.
So it's like being a detective racing against time to piece together the clues before things get even worse. Exactly. And thankfully, we have some specialized tools that can help us in this digital investigation.
Okay, what kind of tools?
Monitoring tools give us real-time insights into the health of our systems.
So they're like the vital signs monitors that you see in a hospital room, constantly tracking the patient's condition.
That's a great analogy.
Yeah.
Yeah, they can tell us things like CPU usage, memory consumption, network traffic,
Okay.
and all sorts of other metrics that can help us pinpoint where the problem might be.
Are there any other tools that come in handy?
Absolutely. Another crucial tool is log analysis.
Okay.
System logs are like a detailed diary, recording every single event that happens in our applications and infrastructure. By carefully examining those logs, we can often trace the problem back to its source.
Wow. So you're not just a detective, you're a historian too, sifting through the past to understand the present.
Exactly. It's all about connecting the dots.
Okay, so once you've found the culprit, what's next?
Then comes the real challenge, fixing the problem. And this is where a DevOps engineer needs to be creative, resourceful, and able to think on their feet.
Yeah, I bet there's no single solution that fits every situation.
You're absolutely right. It depends entirely on the nature of the issue. Sometimes a simple server restart does the trick. Other times we might need to scale up our infrastructure, roll back a recent deployment, or patch a security vulnerability.
It sounds like a delicate balancing act, making sure you choose the right tool for the job without causing further disruption.
Yeah, it definitely requires quick thinking, technical expertise, and a calm head under pressure.
Speaking of things that can keep a DevOps engineer up at night, let's talk about data loss. I know from the material you sent over that this is a huge concern, especially in industries like banking, where data integrity is paramount.
Yeah, absolutely.
What are some of the strategies that are used to prevent this nightmare scenario?
Data loss is definitely a nightmare scenario for any organization.
Yeah.
The consequences can be severe.
Yeah.
Thankfully, DevOps engineers have a whole arsenal of strategies to safeguard against it.
Okay, let's open up that arsenal. What's the first line of defense?
Redundancy is key. It's all about having multiple copies of your data stored in different locations. That way, if one system fails, you can still access your data from another location.
So it's like having a backup generator for your data center.
Exactly. But redundancy alone isn't enough. You also need a robust backup strategy.
Okay.
Think of it like taking regular snapshots of your data.
Okay.
So that you can rewind to a previous point in time if something goes wrong.
Regular backups are like a safety net catching you before you fall too far.
Yeah.
But where do you store all these backups?
Ideally, you want to store your backups in a geographically separate location from your primary data. That way, even if a natural disaster or a major outage takes down one data center, your backups are safe and sound somewhere else.
So even if your primary data center goes offline, you can still recover from those backups and get things up and running again. That's reassuring.
It is.
But are backups the only way to protect data?
Not at all. Version control is another essential tool.
Oh, yeah, we talked about that earlier with code, right?
Right. Remember how we talked about version control being used for code?
Yeah.
Well, it can be applied to data as well.
Okay. Can you refresh my memory? How does that work?
Imagine you have a spreadsheet that multiple people are working on.
Okay.
With version control, you can track every single change that's made to that spreadsheet. If someone accidentally deletes something or introduces an error, you can easily revert back to a previous version.
It's like having an undo button for your data. That could be a lifesaver in so many situations.
It definitely can be, and it's just one more way DevOps teams can protect valuable data.
Okay, so we've covered redundancy backups and version control. What other weapons are in this data loss prevention arsenal?
Another powerful tool is monitoring. And it's not just about responding to incidents. It's also about proactively looking for potential problems before they even happen. By monitoring things like disk space, usage, database, performance, network traffic, we can often spot warning signs and address them before they escalate into major issues.
It's like having a team of vigilant guards constantly patrolling your systems, looking for any signs of trouble.
Exactly. And then, of course, there's the disaster recovery plan.
Okay.
This is like your playbook for dealing with the absolute worst-case scenario.
So if a meteor strikes the data center, we have a plan.
You got a good disaster recovery plan, outlines the steps to take in a major outage or disaster, from restoring data and systems to communicating with stakeholders.
Right.
And just as importantly, it assigns roles and responsibilities so everyone knows exactly what to do in a crisis.
It sounds like disaster recovery planning requires a lot of careful thought and preparation.
It does, but it's worth the effort. Being prepared for the worst means you're more likely to weather the storm and recover quickly.
So far, we've talked about a lot of defensive strategies,
Right.
Preventing data loss, responding to incidents, but we also have to think about offensive threats like cyber attacks. The material you sent over mentions having firsthand experience with these attacks.
Yeah.
Can you tell us more about that?
Unfortunately, cyber attacks are a reality for any organization that has systems connected to the internet.
Right.
I've seen everything from denial of service attacks that try to overwhelm our systems with traffic,
Wow.
to phishing attempts that try to trick users into revealing sensitive information.
So it's like a constant battle to stay one step ahead of the bad guys.
It is. But thankfully, we have a multi-layered approach to cybersecurity
Okay.
that helps us defend against these threats.
Break it down for me. What's the first line of defense?
Strong passwords and multi-factor authentication are essential. It's about making it much harder for unauthorized users to gain access to our systems in the first place.
So it's like having multiple locks on your front door.
Exactly. And then
Yeah.
we have firewalls, which act as a barrier between our systems and the outside world.
Okay.
They block unauthorized traffic and help prevent malicious actors from getting in.
So they're like the gatekeepers of your network, screening everyone who tries to enter.
Precisely.
Yeah.
But sometimes, even with the best defenses, attackers can find ways to slip through.
Huh.
That's where intrusion detection systems come in.
Okay.
They're constantly monitoring network traffic for suspicious activity, and they alert us if they detect something fishy.
So they're like the security cameras of your network, always watching for anything out of the ordinary. What happens if they catch someone trying to break in?
They can trigger an alert.
Okay.
which allows our security team to investigate and take action. In some cases, they can even automatically block the threat.
That's impressive. And on top of all these measures, are there any regular checks or assessments to make sure everything is working as intended?
Absolutely. Regular security audits are crucial.
Okay.
These are like comprehensive health checkups for our systems, where we identify vulnerabilities, assess risks, and make sure we're following security best practices.
It sounds like a lot of work goes into keeping systems secure.
It does, but it's an investment worth making. The consequences of a successful cyber attack can be devastating. So we need to be vigilant and proactive in our approach to cybersecurity.
So far, we've focused a lot on responding to incidents and defending against threats, but I'm curious to learn more about the proactive side of DevOps. How do teams build systems that are inherently robust, resilient, easy to manage?
That's a great question, and it brings us to the core concept of continuous delivery.
Okay, continuous delivery. I remember hearing that term earlier. Can you remind me what it means?
Sure, continuous delivery is all about automating the entire software delivery process. We want to take code changes and get them into production quickly, safely, and reliably.
So it's not just about fixing problems when they arise,
Right.
but about building systems that are less prone to problems in the first place.
Exactly. And remember how we talked about infrastructure as code?
Yeah.
That plays a huge role in continuous delivery. By defining our infrastructure in code, we can automate the provisioning and configuration of servers, networks, and everything else our applications need to run.
So we're treating our infrastructure like software, applying the same principles of version control testing automation.
Precisely this makes managing infrastructure much more efficient, repeatable, and less prone to human error.
It sounds like a very powerful way to manage complexity and ensure consistency across different environments.
It is, and it's a key part of how DevOps teams are able to deliver software faster, with higher quality, and with less risk.
So we've covered a lot of ground in our deep dive into DevOps and cloud computing. We've seen how it's all about building, deploying, and managing applications at scale with a focus on automation, collaboration, and continuous improvement.
Right.
But now I'm curious, what does it actually take to be a DevOps engineer? What kind of skills and mindset do you need to thrive in this field?
That's the perfect question to wrap up this deep dive. And thankfully, you've provided some great material for this.
Yeah.
You've sent us some real-world DevOps interview questions so we can actually see what employers are looking for.
Yeah, those questions should give us a good sense of the specific skills and knowledge needed to land a DevOps role.
Exactly. So let's start with the technical skills. If you're aiming for a career in DevOps, having a strong foundation in operating systems is crucial, especially Linux.
Okay, that makes sense. Cloud environments tend to rely heavily on Linux, right?
They do. Being comfortable with the Linux command line, writing shell scripts, managing system processes,
right?
That's all essential. It's the foundation for so much of what you do in a DevOps role.
So mastering the command line is like learning the alphabet of DevOps.
Yeah, I like that analogy.
Okay, what else is essential?
Cloud platforms are a huge part of DevOps. So familiarity with providers like AWS Azure or Google Cloud is highly sought after.
Okay, so can you give me a sense of what that familiarity looks like in practice?
Yeah.
What kind of skills would someone need to demonstrate?
It's about knowing how to spin up virtual servers, manage storage, configure networks, set up security.
Okay.
Understanding concepts like VPCs, subnets, and security groups is key to building that reliable and secure cloud infrastructure.
So it sounds like you need a solid grasp of networking and security concepts. Okay, to work effectively in the cloud, what about the automation aspect of DevOps?
Yeah.
What kind of tools are essential in that domain?
Automation is where the real magic of DevOps happens.
Right.
Tools like Ansible Puppet Chef or Terraform. These tools allow you to define your infrastructure as code.
Okay.
Making everything repeatable, scalable, and much less prone to human error.
So instead of manually clicking through menus and configuring servers one by one, you're writing code that automates the whole process.
Exactly. It's a much more efficient and reliable way to manage that complex infrastructure.
Right.
And also allows for version control, so you can track changes and roll back to previous configurations if needed.
Speaking of version control, I know it's a big deal in software development, but it sounds like it plays a crucial role in DevOps as well.
It does. Version control tools like Git are essential for managing infrastructure code, collaborating with team members, and tracking changes over time. It's a fundamental skill for anyone working in a DevOps environment.
Okay, so we've talked about operating systems, cloud platforms, automation tools, and version control.
Right.
Anything else that jumps out at you from those interview questions?
Yeah, CI/CD pipelines are another big one.
Okay, CI/CD, I've heard that term thrown around a lot. Can you break it down for me?
Sure, CI/CD stands for continuous integration and continuous delivery.
Okay.
And it's about automating the process of getting code from a developer's computer to a live production environment.
Mm-hmm.
Imagine an assembly line for software.
Okay.
Developers write code, they commit it to a repository,
Right.
and then the CI/CD pipeline takes over.
Okay.
It automatically builds the code, runs tests to make sure everything is working, and then deploys the application to the target environment.
So it's about streamlining and automating that entire software delivery process.
Exactly.
That sounds incredibly efficient and powerful.
It is, and it's a core part of what makes DevOps so effective.
Okay.
It allows teams to release software faster, with higher quality and less risk.
So far, we've focused mostly on the technical skills needed for a DevOps role,
Right.
but I'm guessing there's more to it than just technical know-how.
Oh, absolutely.
What about the mindset and the so-called soft skills?
Technical skills are essential, but they're only part of the equation.
Mm-hmm.
DevOps is all about collaboration, communication, and a culture of continuous improvement.
Okay, so let's unpack that. What kind of mindset is needed to thrive in a DevOps environment?
One of the most important qualities is a strong sense of ownership and responsibility.
Okay.
DevOps engineers are often responsible for the entire life cycle of an application, from development to production and beyond.
So it's not just about writing code or configuring servers, it's about understanding how all the pieces fit together and taking ownership of the entire process?
Exactly. It's a holistic approach to software development and delivery.
Right.
And that means being able to collaborate effectively with developers, testers, security teams, and everyone else involved in the process.
That makes sense. DevOps is all about breaking down those silos and fostering collaboration. So strong communication skills are probably essential as well.
Absolutely.
Yeah.
You need to be able to communicate effectively with both technical and non-technical audiences, explaining complex concepts clearly and concisely.
And what about problem solving?
Yeah.
I imagine that's a big part of the job.
Problem solving is at the heart of DevOps.
Right.
You'll constantly be faced with challenges, whether it's troubleshooting a production issue, optimizing performance, or finding ways to automate a process.
So being able to think critically, analyze situations, and come up with creative solutions is key.
Exactly. And that often involves digging deep into logs, tracing code, and working with different teams to diagnose and resolve complex issues.
The interview questions also mention adaptability as an important trait. Why is that so crucial in the world of DevOps?
Technology is constantly evolving.
Yeah.
The world of DevOps is particularly fast-paced.
Right.
New tools and technologies are emerging all the time, and you need to be able to learn and adapt quickly.
So it's not enough to just master the current set of tools and technologies you need to be a continuous learner, always seeking out new knowledge and expanding your skill set.
Exactly. That's the beauty and the challenge of DevOps.
Right.
It's a field that demands constant growth and learning.
Speaking of continuous learning, the material you sent over mentions a specific experience of learning a new technology from scratch, Apache Kafka.
Oh, yeah.
Can you tell us more about that?
Sure. Apache Kafka is a powerful platform for handling real-time data streams. It's used in a wide range of applications, from processing financial transactions to tracking sensor data from IoT devices.
So it's all about managing and making sense of massive amounts of data as it's being generated.
Yeah.
That sounds incredibly challenging.
It is, but it's also incredibly rewarding.
Okay.
And in this case, the person described their journey of learning Kafka from the ground up. They started by diving into documentation, watching tutorials, and setting up their own test environment.
So they took a very hands-on, self-directed approach to learning.
They did. And they also stressed the importance of joining online communities and engaging with other Kafka users.
Right.
Learning from others who are already using the technology in real-world scenarios can be incredibly valuable.
So it's about being proactive, seeking out resources, and building connections with other learners and practitioners.
Exactly. And ultimately, they were able to successfully implement Kafka in a project.
Wow.
Proving that with the right mindset and approach, you can master even the most challenging technologies.
That's a fantastic example of the power of continuous learning and the importance of embracing challenges.
It is, and I think it's a great note to end on.
Yeah.
If you're considering a career in DevOps, don't be intimidated by the complexity or the ever-changing landscape.
Right.
Embrace the challenge, be curious, and never stop learning.
That's inspiring advice, and it perfectly wraps up our deep dive into the world of DevOps and cloud computing. We've explored the key concepts, the challenges, the tools, and the mindset needed to thrive in this dynamic and rewarding field. Thanks for joining us on this journey.
Yeah, it's been a pleasure sharing these insights with you.
We'll see you next time on The Deep Dive.